All right, guys. So, yesterday in class, we talked about there are four major lines of evidence that support the idea or the theory of evolution. And we covered the first two. We talked about how you can look at the fossil record to really see an actual imprint in rock layers of change over time. And then we also talked about embryology as a focus of kind of support in the idea that we all start developing similarly early in embryonic development before we kind of change out. So lots of embryos look very, very similar. Today, you should have completed the worksheet that we started yesterday on comparative anatomy, and now you're ready to actually take the notes over this third line of evidence that supports evolution. So, anatomical similarities, find this section of your notes. When we are looking at anatomy, when we're looking at the shape of organisms, the bone structure is what you saw in your worksheet. If we find that organisms have similar anatomy, it really can point to two things, and both are supportive of the idea of evolution, just in different ways. And so, if we have similar anatomy, like you saw in the limbs of the human and the cat and the whale and the bat, that is pointing to something called a similar shared common ancestor. So the idea that they all had humerus bones is because they probably shared a common ancestor long ago. They all had an ulna bone. They all had phalanges or fingers because they shared a common ancestor long ago. And so these are called homologous structures. So homologous, we've seen that word before. Homo as a prefix means same. And so structurally, they really are the same. They all had a humerus, they all had a radius, they all had an ulna. The reason is because they probably share some DNA with that common ancestor. And so as you can see on the screen, homologous structures are similar in their structure, but not always in their function. So you examined in your packet or in your worksheet, you examined the bones in a human arm compared to the bones in a bat's wing. You also saw a whale's fin and a cat's arm. They all had the same bony structure, but those appendages function very differently. Your packet worked you through a human uses their upper limb to grasp, to hold. A whale uses their upper limb for swimming and sort of guiding them in direction as they swim. A bat uses their upper limb for flight. So similar underlying bone structure, homologous structures, point back to a common ancestor who shared similar DNA that coded for that humerus bone and that radius bone, but the actual appendage or the limb doesn't have the same function across those species. So if we have similar anatomy, that points back to a common ancestor. If we have, I want to talk about vestigial structures here for a second. That word sounds kind of interesting or weird, but vestigial structures are really leftover homologous structures. They don't really serve the same purpose that they used to. And so as a result, over time, they've decreased in size and also in function. And so there are a couple of common examples of vestigial structures on the screen. You can see that in this whale, the whale still has a remnant of a pelvic bone. Now, our pelvic bones anchor in our lower limbs for walking. The whale, if you remember from the intro video a couple of days ago, whales most likely evolved from land mammals that probably did have some lower appendage that helped them move on land. Now they're swimming in the ocean. They don't need those lower appendages. And so their pelvic bone that attached those appendages is getting smaller and smaller and smaller. They do still have a pelvic bone. It's just not really needed like it used to be. This middle picture is a picture of wisdom teeth. So wisdom teeth are, for many of us, kind of buried in our gums. We don't even know that we have them, but you can see them in this x-ray. The red teeth are wisdom teeth, two on the top, two on the bottom. And when our diet used to be more of like a hunter-gatherer's diet, we needed those extra grinding teeth. Now we don't really need that as much. We eat more meat. We're ripping and tearing, which are the teeth in the front of our mouth. And we're also probably not we're eating more processed foods now than we ever did before. So wisdom teeth, some people are born with all four, some people are born with two, some people are born with none because they're not necessarily needed anymore. And this last picture down here shows this little organ at the very end of your large intestines. That is your appendix. And the appendix long ago was thought to kind of aid in digestion of the diets that we used to consume. Now our diets are so different that it's not really used in a digestive feature anymore. So it's gotten smaller and smaller, you can see, compared to the overall intestine structure. So vestigial structures are kind of leftover homologous structures that really aren't needed that much anymore. And so they're getting smaller and smaller and smaller in size and both function. There's your example of wisdom teeth and appendix. Any of the things that I talked about could also be used as an example. The second thing that anatomical similarities can point to are organisms that developed or evolved in a similar environment. So the first thing that we saw was that similarities, anatomy-based similarities, can point to a common ancestor with shared DNA. This one is a little bit different. This is the idea that maybe we didn't come from common ancestors, but we evolved within a similar environment that offered similar kind of selection pressures. So when we see something like this, these are called analogous structures. So analogous are not the same. So these are going to be structures that actually are not structurally the same, but they help create an overall unified function. So the example that I have on the screen is the wing of a bat, which you saw in your worksheet. Bat wings have bones, and they're more similar to our arm bones than they are to the actual wing of a butterfly. So bat wings have bones. Butterfly wings are not made of bones at all, yet both create a wing structure that allow for flight. And so these butterfly wings are actually made of membranes that are filled with a substance. You can see in this picture down here, those veins, 1, 2, 3, 4, those create the structure of the wing on the butterfly, not a bone, but so not structurally the same, but functionally they both offer flight to these organisms. So when we see things like this, when we see that the structures really are not the same, like we saw with homologous, it's because they most likely evolved in a similar environment under a similar selection pressure. So for some reason, the environment of bats and butterflies, there was a selective advantage provided to organisms if they could actually fly. So that can be your example of analogous structures. So that's really a couple of new vocab words that you've learned today. You've learned homologous structures, you've learned analogous structures, and then you've learned vestigial structures, which are kind of connected to homologous in a sense. So once you take these notes and you have completed your worksheet from yesterday and turn that into the sub, you are done for today.